Warm good morning to everyone. First of all, I would like to thank my CIVILTWIN subscribers for making this channel a great success. Without the subscribers, this is not possible. Just we have started with 0 subscribers. Now we have reached more 300 plus subscribers. We are improving day by day. Today, we are going in a live stream and we are welcoming our speaker, Mr. Harihara Sudan sir. He had completed his undergraduate in Banariaman Institute in the year of 2009 and he had cleared GATE exam with 91 and joined postgraduate in PhD Tech ME Structural Engineering, Coimbatore. And after post-graduation, has joined CAD Software India Private Limited and UK role based MNC company as a junior structural engineer in the year of 2001. He had played the role as a structural engineering in more than 50 projects which are mainly commercial and residential buildings in UK. While working in CADs, become more fluent in international codes like Euro codes and British standards. After working in CADs for 7 years with the aspiration of starting a new company, got resigned from CADs and along with 2 fellow engineers started Compton Consulting Engineering in the year of 2018. From 2018, he is serving as a director of Compton Consulting Engineering Private Limited, which is a young and vibrant firm currently having its main focus on structural engineering and project manager. Once again, we will welcome you, sir.
Yeah.
Thank you for joining here.
Thank you. Thank you, Mano. Thank you, Mano, for the opportunity and your introduction. So it's been it's a long time. I'm going for a discussion with professionals or students or whoever it is in a beginning stage. So it is often very happy to share what we learn on the process of our practice. And we get a chance like this. So I want to share what I learned in my career. So for one thing, it is common for every professional. There is no limit for learning. So the day, every day is a learning for everyone, and we should not think that we have reached the limit. So I feel so I'm in the process of learning, and in the process, I was to share what I learned in my this small career. So today's topic I given as secret of structural engineering. So everyone may be amazed what is the secret in structural engineering. So at the end of the session, I will give what is the secret in a very precise manner, and I hope you will enjoy the session. And to start with, I have some presentation, and before that, I want to share very basic things when if you're want to start as a career to become a professional in structural engineering. And I'm particularly focusing on that small wide road only. Civil engineering is a very vast area. And in this particular area, I just want to give a small focus on structural engineering alone. To begin with, whatever the profession, and it may be a doctor or an accountant or engineer, you should, these are the very small things you should take care. This starts with the basics. Without basics, and like even making a simple shear force diagram and bending moment diagram, you cannot make any great change or great achievement. So the mantra is very simple. It is you're learning the basics correctly. So when you start from your college days, you should understand the concept and what is actually the behavior. You should give more importance for understanding shear force and bending moment, and also the deflection, how the structure behave, and for what kind of action, that is a force. So you should understanding the basics is more important when you start your career as a engineer or whatever profession it may be. So not only an engineer, you should have more understanding on basics. Basics is the more backbone, and you should there's no what I can say escape for that area. So to start with, I'll have a small presentation. Before that, I'll give a very small overview. What is that? Today's session is particularly, I want to take a very small example, or if you're designing a residential building. So it's the same for even if what other scale maybe, if you're designing for a 40-story or a 100-story building, whatever the size may be, the concept is same. When you are possible to design a residential building without any without any fault or missing the concepts. You can do any magnitude of design, so that is not a problem. So understanding the basics is more important. I am keep on emphasizing you should understand the basics first before starting any design, right? Okay. Very small. There are the small example. If you any student, if you come to me for student or those who finished your graduate, they'll come for interview. I'm not going to ask them for a very complex question, or I just ask simply what is the. I'll give some 3-4 examples, like simply supported beam and a fixed beam, cantilever beam, overhang beam, and a simple frame structure, applying a load like UDL or point load, and ask them to draw this bending moment, shear force, and deflection. So if a engineer or the graduate or whoever looking for a job, if he is able to deliver that idea, that is, if you do good in basics, then I think you can excel in the engineering without any hindrance. I'm assured that if you're very strong in basics, no one can stop me. So please understand, students who are preparing for your exams, or even you're looking for some MNCs to crack the interview, you should understand the basics first rather than learning the theories or whatever. I believe in basics rather than remembering things or collectively or understanding some theories, or those are not necessary for professional. And if for example, if I ask a student or giving an example, like draw a cantilever beam and you put a reinforcement, drawing a bending moment shear force for a cantilever beam, and if I ask them to draw a reinforcement, just simple example I will give, and people will be there are smart people, they'll do good, and most of the people will struggle hard making shear force and bending moment even for a simple cantilever beam. They will put in reinforcement at the bottom, and they'll somewhere be putting at the middle. So if you understand the concept, so why we are going for a reinforcement in the concrete, and what is the nature of RCC. So if you understand these things, you can easily crack the interview or whatever it may be. So even you can excel in your professional. So understanding the basic is the main concept. So you should understand the behavior also. If I give, I used to give this example. If I hold a bucket of water in hand in a just straight position, what is the type of action of forces which will make in my joint? That is in my joint. What kind of action it will take? Whether it will take any moment here, or it will take simply a vertical reaction will be there, or what is the shear will be there. So I'll be asking, and the same bucket, the bucket is going to be the same, and the member, that is like your hand, is going to be the same. So if I ask you in this position, what kind of force it will happen in the joint, people will be struggling. If you understand this thing, this small example, you can clearly imagine what kind of force act when what kind of support condition. So this is the thing you have to understand before going to understanding the engineering, right? So straight away I go to the presentation. I would just like a very small introduction on structural engineering. I'm not going into deep, all right? So I'll right away share what I have with me. Yeah. Hope you can visible. Mano? Hello?
Hello? Yes, sir. It's visible,
hello,
sir.
Visible, right?
Yes, sir.
Yeah. So to start with, so my topic is on secret of structural engineering, right? Yeah. So there's a very small, very basic example. Do you know a doctor's mistake is buried, but an engineer's mistake is exposed? So do you understand what it means, right? So when a doctor commits a mistake, he may die, and he will be buried, and it's been closed, right? But an engineer's mistake is done, it is going to be disastrous, right? So it will be exposed in all over the time. People will be commenting that this has been a big mistake by an engineer. So there's a big responsibility of an engineer. We should not commit any collapse, you should not be responsible for any collapse. It's happened. You can see in the news often that there's been a big bridge has been collapsed, and the high-story building has been collapsed due to under design or missing the concepts, or so and so on. So you should understand. Understand your responsibility first before going into your profession. So this is a very if you have the fear of if the reaction when you do by a fault or whatever it may be, then this fear will make you keep on checking whether I'm doing right, so you should always have that fear. You should not miss the concept, right? So if you do a mistake, then it will be going to be a very catastrophic failure, right? So if you start with the building design, so generally, if throughout this presentation you just assume I'm telling about for an simple residential building or even a small size commercial building, not going to be a industrial structure or some warehouse design or factories kind of thing. You just assume a very small commercial building or a residential building, right? So if you take the building design, so particularly architect will be the pioneer for any projects. So he'll be making he'll be discussing with the client, and for his requirement, he'll be making the layouts and where you have to position the various functional buildings and where to place the other utility buildings. So he'll be the coordinator or the pioneer. So he'll be calling on civil engineer or structural engineer. Then he may call a mechanical person, like those who do AC and whatever firefighting and other plumbing team will be there, and electrical team will be there. So these are all the four major teams will be coordinating when you're working on a project. So these persons are the backbone of any design. If you connect with the design, right? Yeah. Then, so for in this particular, I'm focusing only on civil or structural. Other three divisions will not cover in our topic, right? Yeah. So in civil structural, you should start with the conceptual design. Then you have to make a schematic. Then you will be doing a detailed design, right? In the conceptual design, what we do actually is we'll be discussing with the architect, and we'll be phrasing whether we should go with RC structure or steel structure or precast system, and a lot other technologies have been booming. So you should understand what kind of structure you should to begin with, whether if it is a very small commercial building or if it's a particularly residential building, it will be mostly RCC structure. And if it is a small commercial building, nowadays steel structure also it is viable in many of the cases. So for example, if you're designing for a car showroom or whatever, even for hospital, small size hospital also, nowadays they are doing a steel structure. Every option will have some limitations and also have advantages. So analyzing all the aspects, you have to freeze the what is the concept, you have to freeze it, right? Then precast system is also now one of the emerging technology. It has its own advantages and also limits, right? You should understand, and you have to fix accordingly, right? Yeah. Then going to the scheme design. So once you've been you have fixed the structural system, like whatever you are going with an RC system or a steel system or whatever precast, and you should keep other next level of development is you should freeze the what is the member system, like what is the kind of horizontal members we can go, and what is the kind of vertical members you should if you are going to opt, right? Yeah, if it is for a horizontal member, whether you are going for a conventional slab beam system, it is one of the old system where you can see the deep beam and slab along the horizontal members, right? And flat slab, you will not have any beams will be available, and you can see the column capital or column head at the column position, right? Wherever column supports the slab, you can find the some deep column head at the level, right? Then other option like flat slab with PTT. When span is more, if you want to restrict the slab depth, you can go with PT option also there. And other thing is like composite steel floor decking. It means it's a combination of you'll have a steel as well as concrete. So you should freeze the system of horizontal members and vertical member in the schematic design level. And for vertical members, so vertical members generally resist axial loads, and also so bending due to lateral forces like seismic or wind force you have to consider, right? This lateral force you can it will make a moment lateral force. It will generate shear and moment in the vertical members, and you should decide whether columns alone should take lateral force, or column shear walls should be taking the entire lateral force, or you can also make dual system. The part of load will be 25% of the lateral force will be taken by columns, and 75% of the lateral force will be shared to the shear walls. And if it is in a steel building, normally bracings will be the lateral force resisting members. So these are the things we will freeze in the schematic design stage, right? Okay. In detailed design, you will be doing the structural analysis of if you freeze this scheme. So you'll be modeling, or you'll be analyzing using the manual tools. So any stage you should be very confident that you should be a master for your design, and you should not rely completely on computers, and you should not master you. You should master the computer. It's just it's a tool. Just whatever the instruction we are giving, it is analyzing to make the time and cost efficient. That's it. So computers, we should not allow the computer to master us, right? And any output computer is giving, you should able to justify whether the analysis is giving the correct behavior. When you do a small conventional assigning, it will what will happen means it will become the other way it will be giving. If, for example, for a simply supported beam, rather than giving a bending moment at the bottom, it will be it will be showing at the top. So it is entirely opposite. So when you do some assumptions, or when you're feeding the input, you should be doing it very correctly, and also you should able to justify, or you should able to check whether the computer is giving a correct behavior. And you should often check, and you should not simply believing on computer to do everything, and you should not follow that way, right? Yeah. So then you will be doing analysis, and after that you will be doing an element design. You should be designing starting from the foundation, columns, beams, and slabs. You will be every element. You will be taking the loads and its reactions. You will be designing the elements. Then you will be based on the design. You will be you'll make the RC and RC or steel. If you will be making drawing, and you will be releasing to the site for construction. So this is a very normal procedure in any design, right? Yeah. So it's a very small example for to understand how each element behaves in various kind of forces, right? So it's a very simple bridge you can see. So in this, if any vehicle is coming in and over that, so you should know what kind of force it will make it in every members, right? Here you can see there are two members. One is a horizontal member, that is the slab portion of the bridge, like a horizontal portion, and another is the column. You can see there are two columns supporting that bridge, right? Yeah. So in this, when a vehicle or some heavy vehicle is standing on that bridge, you know what forces will have on column, right? You can see clearly that concrete in the column it will experience compression and maybe a moment based on the slenderness, right? So mainly it is a compression force will be the predominant force in column. So if you come to the horizontal member, I can divide it into 6 portions, like in the end, top and bottom, the left end, top and bottom, middle and top and bottom, and right and top and bottom, right? So I have shown 6 boxes in the that area. Whatever the kind of forces you should have to fit it, right? For example, in the left top, what kind of force it will act? Anyone can see it's like a continuous beam. So it's very common sense that in the left top and middle bottom, it will experience tension. And also the same thing in the right top, it will experience tension. It's very clear. And the other things will be, other areas will be the compression, right? Yeah. So it is very clear in this picture. So this kind of behavioral deflection will happen in that bridge. Not this much degree of freedom deflection will not happen. But to understand, this is the behavior the horizontal member will undergo when a force acts like. So you can see where are the portions you can get the tension and where are the portion you get compression. So this is a very simple example. If you understand this small basic, you can do any design, right? Yeah. So what we do, if you go to the design, so you can now you are very clear that where are the portion we go tension. So why we are generally inserting steel inside concrete? It is to take the tension, because tension is the concrete cannot take tension. It can take tension, but it's very negligible when compared to steel, right? Yeah. So to make the member more effective in tension, we are inserting the steel. So you can identify where are the places it will go tension. So you will be inserting the steel for that. The red line, you can show that for this was tension steel, and at the bottom and at the top at the support. So this is the thing you can see any continuous beam. So in the bottom member, you should in the middle you will be finding the tension member predominant, and then the support top members you will be up to the tension steel, right? And you will be giving the minimum continuous to make the continuity reinforcement. You will be providing the some minimum steel to hold the shear links, right? So shear links will take care of the shear forces, and you can compare with if you make a shear force diagram, and if you do the shear link reinforcement design, you can understand why what is the importance of shear links, right? Yeah, this is how a complete design of a one continuous beam. So you can see the tension reinforcement, and you can see the shear links as shown in this presentation. So you can easily understand. So how we have to for what forces we are going to design, and what kind of impact it will go in each element for the forces, right? Yeah. And it is a very small comparison for concrete and steel. So when you take concrete, it is very good in compression, but not in tension, right? You can see the first thing in tension, concrete is very pure and steel is good. For compression, both are good, but steel, if you're going for a slender member, it's going to be, so it have very good tension compression capacity, but when it is going to be slender, its compression capacity will reduce. So going for a shear, concrete is fair, but not say poor, but it's fair, but steel is good, right? For durability aspect, concrete is very good, and steel is not good, it is way poor. If it is properly, it is not protected, it will go corroded. So that's why the reason we are giving a correct cover for the elements. Like when it is a foundation, we'll be giving more cover. When it is going to be a beam, it will be giving some cover. For the column, we will pick some cover. For the slab, we'll have some cover. So it is just this cover, the concrete cover will protect the steel rather than based on the exposure condition. If it is a say a seashore area, we'll be giving some cover. If it is a tropical inside area, we'll be giving some cover. It acts like a protections to the steel, right? Okay. Then resistance to fire. Concrete is good in resistance to fire, but when steel is not good for resistance to fire. So that's why this cover will play. So when you want to fix a 2-hour fire rating for some important structures, you have to increase the cover. If you want to make a 1-hour cover, there will be 1 hour fire rating. You have to put some cover. If it is a 3-hour fire rating, you should increase the cover. So based on the fire hour rating, you should decide the cover for each elements accordingly, right? Yeah. Then you have to see the order of design. How if you completed any model, like if you done it in any softwares, you should start with the designing of beam, then beam to slab to beam, beam to column. Then you have to finally take to the foundation, and you can see why we are going in this order. So So initially you can see that you'll be putting the slab loads on the slab member. From the slab, the load will go to the nearer beams in whatever the distribution aspect. It is a two-way distribution or one-way slab. So based on the kind of distribution, the loads will be transmitting to the nearest beam member. So that all this the beam forces in the beam will collectively go to the columns as a shear force on each beam connecting to the column, right? So beams transmit their loads to the column. Then column in turn, it will transmit to the foundation, that is footing, whatever you are putting. So then that from the force that from footing to it will transmit to the soil based on the bearing pressure. So if you want to design the foundation, the bearing pressure of soil is more important. You have to consider, you have to do the soil investigation, and if it is a very rocky terrain, you can see the footing size will be very smaller. If it is very loose soil or something like clay or so bigger soil, you can find the soil the footing will be of higher size, right? Yeah. So the idea is what is the role of an structural engineer or civil engineer? If you are doing a design for any type of building, the key idea is you should transmit the whatever the force you are making in the functional area. For example, if you are designing a school building, so your purpose is to serve the area for classrooms. So where the loads like students will be there, and their benches, tables, or whatever the materials will be loading on that, right? So the load will be due to all these the dead and live forces has to be properly transferring from the slab to the beam to the column to the foundation. So that is the core idea of the structural design. So you should understand what are the forces will come to every element, and how each element will behave for that force, and how you are reinforcing that member, and how you are designing that member. This is the key idea, right? And how to design, you can use either by manual or computer. Again, I'm emphasizing, when you're using a computer, it's a computer is just a tool. So you should master the computer, and you should not allow computer to master your design, right? Yeah. So basics for modeling, the same thing which I've told earlier. You should design every element like column, beam, slab, and footing. Then you should assume what are the kind of support condition you are making for your design. So it is all deals with the philosophy of designer who makes his design. So someone may make it as like a fixed support, or someone they can assume like a pinned or roller or whatever it may be to that case. So it is all the design philosophy, the choice made by the designer. Okay, and you should understand the load. What are the load comes to the structure, the dead, live, and lateral loads like seismic, wind, and after that you should make the combinations according to the codes. So if you are working on a particular country, you should use that combination which their code says. So for example, if you are working for an American building, you should use the ASC codes. Not you cannot use Indian codes or other codes. So it's all lies with the client, right? Whoever wants that design. So the packages are available, like for modeling there are some softwares, and for the analysis and for drafting you have softwares. Again, I'm telling you should use this as a tool only, right? Yeah. This is a very interesting thing. What it means is it's not only a building. If you take any structure or any machinery or whatever it may be, it will have their own kind of forces. It will act on each of its member. For example, you can see what kind of stresses it will happen in the wheel and other elements, like you can clearly see. So even a person who designed the cycle, he should understand the forces and its impact, how the structure behaves. So accordingly, he will be giving the design, right? Yeah. So these are the codes. So I just want to put it to your view that there are there are standard codes for their whoever design for any projects for that country. You should follow that code, right? Yeah. And for example, Indian standard codes, if you want to do for RCC, you should follow IS 456. For taking the loads, you can see IS 875. And for a steel structure, the IS 800 is the code. And for earthquake design, it's IS 1893. And ductile detailing is IS 13920. Similarly, for each kind of elements, you should not like elements for a timber design. There's one code. For PT design, there's another code. So you should follow the. You should refer the standards when you're going to the design, right? Yeah. So finally, I will conclude like in structural engineering, the idea is you should identify what are the loads to be resisted, then how you are taking the load path. So you should assume correct load path. If you are going for a conventional system, or if you are a steel structure, what is the idea? What is the kind of load path you are taking? If you are going for a truss system or a arch system or a frame system, whatever it may be. So that load path you have to define, and that load path in this slide path you have to go for an economical and safe design. That is more vital important whenever you are going for a design. So what is the difference between a professional and those who are practicing out of their experience? Means when you are going for a professional approach, you will be analyzing and you will be doing the exact safe and economical design you will be giving. When the persons like those who have been by experience, those who are making the design, so sometimes they may go uneconomical, or sometimes they may under design also. There is a chance. So the professional approach is the most safer and economical approach. You should understand that one, right? So with this, I will make a very small conclude my presentation, and I'll also show some of the drawings. So for drawings to understand for better understanding, right? Yeah. Hope you can see the drawings, Mano. Hello.
Sir.
You can hear the drawing, right? You can see the drawing, right?
Sir, have you opened that? You can select that window, sir.
Yeah, you're seeing the PDF file, right? The ground floor and first floor I've just shown. You're viewing, right? Currently?
Sir, wait a minute, sir. Sir, go to that presenting window, sir. Select that window, sir.
Okay.
Sir, go to that presenting now, sir. Present now.
It's already present now only. I can see that.
Okay, sir. Select the window. Yeah, window. You can choose which window you need.
Actually, that is not coming. You are presenting.
Sir, you can close that PPT, sir.
Okay, you stop presenting, right? Yeah. Now we'll go to
Present now.
present now. Yeah, a window, and yeah.
Okay,
You
sir.
can see now.
Okay,
Yeah.
sir. We have seen that.
Okay. Yeah. Uh, yeah. Hope you have been seeing, right? Yeah.
Yes, sir.
Yeah. So in this, you can see you're seeing, right? So you're seeing, right?
Yes, sir.
Yeah. So this is one example you can see for a residential building. Normally, architect will be making the layout for any residential building or whatever the structure may be. And what we have to do is we have to fix the column position in such a way that the architect will may have some idea that if he just please avoid a column here, so we have another utility is going to come, and it will otherwise it will look not aesthetic, and he'll be telling a lot of reasons. First, what we have to do is we'll be tentatively we'll be fixing the column and we'll be giving to the architect back. So he will comment and just to extend the column to the side, or just kindly you can avoid this column. We need please try and avoid this column. So he'll be commenting various comments he will give. So this is a way to start with when architect has completed the layout. So we'll be doing the column position. Then after coming to a conclusion, we'll be placing the column positions. Then what we'll do, we'll make a design. We'll make analysis model in the tool which you are going to opt. So is my drawing moving, Manu? You can see whether my drawing is moving.
Yes, sir. It's moving.
Yeah. Okay, fine. So what happened means then you will be then we fixing the column position. Then 1 minute. So this is can you see the column footing drawing?
Yes, sir.
Yeah. So this is the footing drawing. You will be making the, for example, you will be after fixing your column position, you will release such a drawing to make the excavation and to excavation, or also to make the footing design. So you're making the footing sizes, and you're making the grid first, and you'll position the column. Then you'll make the footing sizes. You'll be giving the offset from the grid to make it mark in the construction site. So based on the drawing, they will be excavating the soil, and they will put the PCC, and they will make the RC concrete pour according to the design, right? Okay, yeah. Then coming to the column design. So now we can you see the column drawing now?
No, sir.
No, yeah, sorry. Yeah, there's a layout column you can see. I think, hope you can see now.
Yes, sir. We are seeing, sir.
Yeah. Okay, fine. So after making your footing setting out, then you have to you should give the column setting out. So based on the grid, fixing the column sizes, you will be telling this much of offset you have to make from the grid, and you will be fixing the column that you can do manually in the site, or you can use also digital surveying. to fix the column faces. So this is a footing and column drawing. So setting out drawings will be issuing to the site to make marking at the site, right? Then you will be giving. Yeah, then you'll be giving the plinth beam design, right? Plinth beam design. You'll be making the layout. So based on the sizes, you'll be giving the reinforcement. So what are the top reinforcement? What is the bottom reinforcement? And what is the shear lengths you will provide for the that beam? So you'll be making the beam IDs like PB3 or PB1 and PB2, and you have to refer the schedule for that design. You can. So the bar bender should follow this schedule, and you have to make the reinforcement. And after you're doing your farm work and placing the steel gauge, and you have to concrete it. And in this, there are general things you have to give. It's like you have to give the cover for the concrete structure, like for a beam. So you have to show what is the cover you should use, and for a slab, what the cover you should use, and what is the grade of concrete you are going to use for that concreting, and what is the lap length you are suggesting to implement at site, and these are the general instruction you should give while issuing the drawings to make work at site, right? And this is a general lapping arrangement for a beam structure. This will be helpful when he makes the reinforcement placement at site, right? Yeah. So after making the plinth beam design, you should be giving yeah. One moment, please. Yeah, fine. So there's a yeah. Then after completing your plinth beam, then you should issue the roof beam structure for roofs, ground floor roof. You have to give the beam design. So similarly, you should make the beam layout and what is the size of the beam, and how you are the setting out. This cantilever has to become 5 feet from this edge of the beam, and all the layout you should give. And accordingly, for that beam ID, you will be giving the reinforcement in the schedule column. So they will follow the reinforcement in the and they will be placing their reinforcement accordingly at site. And for the cantilever beam, you can see generally. So you can see the predominant bars at the top. There are 3 bars at the top, and bottom there is only 212. Probably it be a minimum reinforcement you should be giving. So these are the things when your software gives some higher reinforcement at the bottom for the cantilever beam, it is absolutely wrong. So something has went wrong. You should identify that one, and you should keep on checking the concepts then and there to avoid the blunder or fault at any level, right? Okay, this is the way you will be making the reinforcement schedule for the beam structure, right? Okay. So then you will be doing finally you will be giving the design for the slab design of slab. So whether you are making it a 2-way slab or 1-way slab, so you'll be freezing your design concepts, and you will be issue the drawings based on your concept of what you're considered for design, right? So this is how you'll be giving the slab drawings. Like you can see here, you can see here there's a reinforcement dia, 8 dia bars at 6 inches spacing, and what is the curtain bar where you have to stop it, and the distance they are shown here, 2 feet 10 inches, and all the things you have to give in detail for construction site. So these are the very small procedure you can see when you're doing a design for a small residential building. this is the same process you will continue, or you will be continuing for any size of building. It will be, whether it may be the 50-story or 100-story, the concept is going to be the same. Only the magnitude of design will be high. So I keep on emphasizing that you should understand the basics first, and then you go for the design. So when you're studying from your start of the career, or when you're at the studying level, whatever it may be, just put some extra time for your understanding the concepts, rather than just you preparing theory. So that will helpful for your professional career, rather than putting the idea. You're just learning the what is that, the theory part. I never encourage that one. So you should understand the basics. So moreover, I think I've covered a small, I have given my view on small design for a small building. So when you're doing a complex part, there are a lot of things you have to consider, and that we'll see in a detailed design presentation. And to conclude with, in the starting I have told there is a secret of structural engineering. So the secret is nothing. My secret is common sense. That's it. So there is nothing big secret on structural engineering. The common sense is the only secret of structural engineering. If you understand the basics, that is going to rule the design. So, for example, as we were told earlier, if you're a cantilever beam, your common sense should tell that you should put your reinforcement at the top and not the bottom. So that's it. That's a very small secret, and there's a big, smaller. Not small, it's a big secret for structural engineering. Yeah, thank you for the opportunity, and hope everyone got benefit. Yeah, thank you. Thank you, everyone.
Thank you, sir. Thank you so much for sharing your secret.
Manu? Yeah, thank you, Manu.
Some of the friends has asked some doubts, sir.
Yeah, please share.
One of the friend named Mohammed Rafiq asked, sir, in design software like ETABS, why we are doing release or partial fixity of simply supported beams?
Yeah. So, for example, in ETABS, if you're doing if you're making a beam to behave as a simply supported, so what is the concept of simply supported beam? There's no moment at the support, right? Only moment will be you can see the moment at the middle bottom only. So it's a very simple curve, like a smiling curve. It will happen. So we are not allowing any moment to the supports. So if you're not assigning the partial fixity, if you not release the moment for the major axis moment, you will be using the term my in the ETABS. So if you're not release the moment, what will happen means in the support it will take moment at the top. The beam experience what is that? It's like hogging moment at the support. So if you want to make it will to make behave like a simply supported, you have to definitely have to release the beam at the in both ends. So that you can make a behavior of a simply supported beam. That's the reason.
Okay, sir. Thank you, sir. I think Mohammed Rafiq, you have quite a clear idea about your doubt. Sir, and next, Vikamangshin Rajput have asked how to create an efficient model.
You have to create an efficient model.
Yes, sir.
There is nothing but you make an efficient model. It's like, I can say efficient model in the term, like it's like rather than if you in a ETABS design, whatever the software you use, you need not to be you should not make exactly. You should make I will not recommend whatever the architectural view. You need not to make it. Like, for example, if you want to make a staircase, you need not to make like an inclined base slab and things. You can put it in the same level. You just apply the same load, and whatever the final idea is, we should get the equivalent weight of that structure. So these are the small things. If you correct it, if you want to make an inclined thing, you have to make another reference plane, and it will take some time also. So understanding the concept, if you understand the concept, and if you design based on if you make the output to your concept, then you can minimize the effort in making the model for whatever the software you use, in SAP Pro or in ETABS. So like what example I told, if you want to make a staircase, you need not to be put in a inclined position. You can put it in the same level, apply the same load what it comes to the stair, and finally what our idea is to take the load from the stair. So automatically it will take this kind of small steps if you follow. So you can avoid time, you can minimize your time so that you can make an efficient model. Hope it will answer your question. Right.
Yeah, sir. Thank you, sir. And another friend Nandini have asking that what about composite structure design?
Composite structure design is a separate area where the behavior will not be the same like what you see in a normal conventional beam. It's a mixer of steel and concrete portion. So it's an entirely different area. I think in a separate presentation I can give on composite area. I think you cannot mix it with purely steel structure or purely concrete structure. It is going to be another mixture of design. So the behavior will be different rather than your conventional RC or steel system. Yeah.
Okay, sir. Thank you, sir. That's all doubts, sir. Thank you for sharing your useful knowledge and your secret behind your structural engineering and your company, sir. It's very much useful for you. Thank you for spending your valuable time for us, sir.
Yeah, thank you. Thank you, everyone. Yeah.
Thank you, sir.
Thank you.
Okay, sir. Shall we wind up, sir?
Yeah, please. Thank you.
Okay, sir. Thank you, sir.